is the helper of our instructor. I don't know. But
No.
okay, he scheduled 2 meetings, and
Oh.
I thought he will send us a recording, but I communicated with him, and he said he won't send a recording. But I told him that I need help. I am struggling a lot in finding, in knowing what statistical procedure to choose. And he told me he will meet with me on Saturday, 8 a.m. And I told him that I will tell you and Gabriela in case you need help. And he said it's okay.
I don't think I can meet them, but thank you.
Okay, okay, okay. You're welcome.
Let me see here. Here were my answers that I did earlier, just a little while ago.
Okay,
But I'm going to close that down
okay.
and go to. Okay.
Did, sorry. Did Gabriela send you the responses? Her
She did.
responses?
Yep. She sent them to
Oh,
both of us in the email. It's your Gmail
you
account.
know, I didn't find it.
Let me see if she
Maybe
sent it. You know what? Well, I think she
I
maybe
think.
sent it to. Yeah, she sent it to your email address without the 733 in it.
Oh, that is why. Yes,
Yeah. Yeah.
I. Yes. Can you please send it to me to the
Sure.
733? Thank you. Thank you very much. So,
Um,
please.
let's see here. Okay, that's on its way to you. And I
Okay,
think I
thank you.
need to go ahead and get these up and running here.
Okay.
This was a lot of work today. It's
Yes,
kind of a pain.
yes. And I got, I am struggling a lot. Oh, thank you, Karen. I got her answers now. Okay.
Here's the direct flights.
Okay.
Bone density next. Hummers.
Sorry.
I'm opening up the Excel spreadsheet for Hummers,
Okay.
about the car Hummer.
Okay.
Okay. And then trying to remember. Okay. I think that's what we need there.
Okay,
all
thank
right.
you.
So we can go ahead and get started, I think. Let me make sure we're recording.
Okay, thank you. Yes.
Yeah, we're recording. Yeah. Okay. So true to we're participating in the lesson. I'll do the first one if that's okay.
Okay,
So,
please.
so given a 90% confidence interval of 45 and 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? We are 90% confident that the true mean heart rate is between 45 and 105.
Yes, I agree with you.
Okay.
Yes, I agree with you. Next, it says researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go made stimulus of males different from that of females. The researchers randomly selected 20 females and 15 males to participate. The go, no go stimulus required the students to respond to a particular stimulus or other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create two plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? Okay, I think yes, the requirements are satisfied, and the distribution of the mean of each sample is normal since the data have been determined to be normal.
So this one here.
Yes, the third one, yes.
Okay. So the next one, number 4, would be for Gabriella, and it reads, of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? And
Okay.
she says, let me pull up her email.
Okay.
Yeah, she says confidence interval for the means, the difference in means using independent samples, which I agree.
Okay. Okay. Would you like me to no? Can you please explain me? Because I got it wrong and I didn't know why.
Yeah. So of the 4 types of confidence intervals listed below, which one's appropriate for the experiments? So we want to find the confidence interval for the difference in means using independent samples. So the reason that they're independent samples is you have 20 females and 15 males, but they're not related anyway. Group B had nothing to do with the selection from Group A and vice versa.
Oh.
So you want to know the difference of the means, right?
Yes.
The difference between the means of the women and the men, but they're independent samples because the 2 groups don't have anything to do with each other. They're not, well, that's not maybe the best way to put that. The sampling of Group B had nothing to do with the determination of the sampling of group A. Does that make sense?
Okay. Yes, yes, I understand now.
Okay.
Thank you. Okay.
So 5 here, I think, is for me. And it says a researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be 3402.08 and 4142.75. Which of the following would produce a confidence interval with a smaller margin of error than 95% confidence interval?
Okay.
So we know that the more samples we have, the closer the standard deviation is. And this is basically the standard deviations, the margin of error is the higher bound standard deviation minus the lower bound. So by making 90 customers rather than 30, it would make a smaller margin of error.
Okay. Thank you. Thank you. Wrong, and now I understand it. Thank you.
Sure.
Okay. A factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95 confidence interval for the true mean length of the shafts. Okay, what I did here is I used the formula x bar, no, gross minus z times standard deviation divided the square root of n. And in that way, I knew that our lower and upper numbers
Bounds,
and
yeah.
bounds. Okay, thank you. And then
So why
in
don't you
that
give
way,
me those?
Sorry?
What numbers did you get there? The lower and
Okay.
upper bounds?
Yes, I got 998.040, and the upper one 1001.960. So I what I did there then, it was I subtracted the lower bound from the upper bound, and the result I divided in 2, and I got, oh yes, you are in the, okay, and I got 1.96 was the confidence interval.
Yep.
Yes. Okay.
Yep, plus or minus 1.96. I agree.
Okay, thank you. Yes.
Okay, so I think it's Gabriella's turn. And it says,
Okay.
to assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean, and standard deviation is 0.01 grams. How large should n be so that a 95% confidence interval for the mean has a margin of error of plus or minus 0.0001? And she wrote, and there's a she just used the formula for calculating the N. She wrote 38,416. Is that what you got?
Yes, it is what I got also.
Okay. So I think it's back to me. It says the mean
Okay.
area of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis, null and alternative for the mean are, and it would be the last one, right? Because
Yes,
we want to know if it's smaller. They believe it's smaller is the alternative.
Yes, I agree with you. Okay. 11, in a statistical test of hypothesis, we say the test result is statistically significant at the level of significance if, okay, I got it wrong. And let me check. Oh, no. Can you please help me?
Yeah, it's if the p-value is less than the level of significance.
Oh, okay. Oh.
So in other words, the alternative hypothesis has such a low level of being an error when the p-value is less than the level of significance that you would reject the null hypothesis. Does that make sense?
Okay. So so let me.
Here we can kind of go here and if we look at this, I think we can explain it probably
Okay,
better,
thank you.
right? So
Thank you.
what we're measuring, right, in the null hypothesis is either this or this, if it's right or left-tailed or both. And we're saying if the p-value is less than, up here, if these two are less than 0.05 or whatever the level of significance is, then that means that the chances of getting the value that we got for alternative hypothesis, because remember this represents the alternative hypothesis, is what we're running here.
Okay.
Then if it's less than 0.05, then the chance of the alternative hypothesis being just by chance received and not because it was accurate is really, really low. And so the chance of it being just received by a fluke is really, really low. If the p-value is under that, then you say that the alternative hypothesis is likely. And so you reject the null hypothesis. Does that make sense?
Yes, that makes sense.
I get that confused all the time too, by the way. I have to remind myself all the time.
Oh, thank you. I struggle with that. Thank you. I got it now. Thank you.
Okay. Is this Gabriella's, I think?
Yes.
Okay, so then she says, so let me read it first. A group of statistics students wants to determine if students in some apartment buildings getting better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data from each apartment building are well-shaped with no outliers and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer this question? And she says, I think this is what she says, yes, it is enough that the data for each apartment building are well-shaped with no outliers and the sample variances are nearly equal. And I agree with that. Do you agree?
Okay. I got it wrong. Just let me check it if I understand it, please. Oh. Okay, you know what? It was confused to me. It was that it says it's talking about a bell shaped, and I understood that the ANOVA would be just right skew. That is why I don't got it.
Yeah, the findings, but each of the sample sizes, okay, so when you're doing the ANOVA hypothesis test, it's right skewed. But each of the samples could be bell shaped.
Oh.
Okay. So and yeah. So does that make sense?
Yes.
Okay.
I understand. Thank you.
So what's the next one here? A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at 0.05 significance level. Consequently, she rejects the null hypothesis. In the future, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has committed a type 1 error. So type 1 errors is when you reject something that shouldn't have been rejected.
Okay.
When you reject a null that shouldn't have been rejected. Does that make sense? Do you agree?
You know, now I understand a little because I struggle a lot with also the type errors. But you're telling me that we commit type 1 error when we reject something that we shouldn't have rejected, right?
Correct. That's my understanding of it.
Okay, thank you. Okay, the next one, it says, if the level of significance is made very small, thereby making the probability of committing a type very small. What happens to the probability of committing a type 2 error? Ah, yeah, making the probability of committing a type 2 error. No, I am lost, you know.
The only thing what you need to remember is that type 1 and type 2 have an inverse relationship. So if one goes up, the other goes down, and vice versa. And that's always true. If you reduce the probability of type 1, you increase the probability of type 2. If you increase the probability of type 1, you reduce the probability of type 2. They're inverse.
I didn't know that. Okay. Okay, and we are increasing, right?
It said that we're reducing the type 1, so we would be increasing type 2.
Type 2. So it would be by reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
Right.
Okay. We increase. Okay, the first one. Thank you.
Okay, so this is Gabriella's. It says the nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis that the null is mean is 1.5 and the alternative is the mean is greater than 1.5. Okay. And she wrote, reject the null.
I agree with that.
And which formula did you use?
Let me check.
I got that too, but
Okay. I got, I think I used that. Let me see. Okay. What I did, I got the 1.53, but I am trying to know why did I get that. Okay, I think I Z equals X bars minus mu divided the standard deviation divided the square root of n. I think I use it. And then I got, no, I didn't use it.
so I think we just needed to find out what the z-score was. Right? So right,
I
so
don't
that
remember.
I think that's what we're looking for.
Oh.
Is just that we're taking all we're really doing is we're taking the one minus the other over the standard deviation, right? So I think it's so it's 1.53 minus 1.5, right?
Yes. Yes, I wrote here 0.03
divided
it's,
by 0.17. Oh, 0.17, right? So that's 0.176.
Oh.
And what's the rule about p-scores?
It says if p-value is less than our level of significance, we reject our null. Like you there 0.86, right?
Yeah, but hold on just a second. I don't think I did that right.
Okay, let me see. What did I do here?
I got it right too. That's what's funny. And now
I don't remember. I just wrote 1.5 minus 1 equals 0.03. And then I wrote 0.03 is less than 0.0, because it says at the 5 level of significance, you conclude that you should. And that the 5 percentage, I said, it is 0.05.
yeah, but I don't think that's
The right, way, right?
Well,
Mm, I
actually,
don't
maybe
remember.
that is what you do. Now I'm
But
completely confused. Hold on just a second. Let's see if
okay, okay.
the standard determining confidence interval.
Oh, let me see. Carpacenta.
I don't know why I'm getting caught up on this. This is easy. Um,
Okay. I don't know. What did I do? Hmm.
hold on just a second.
Okay, don't worry. Oh, maybe.
Well, but we need two means to do that, right?
Yes.
I don't know why I'm having a brain freeze here.
Don't worry. I am the same. I don't know why I got that result. I just wrote that. Let me check.
Okay, I need to do some research here, but I think that this would give us our. I'm really messed up here, but it's 0.03. It's less than, so we reject.
Yes.
So
I don't.
I need to go back and look what formula I used. I had when I was doing this earlier, I had open the chapters review,
Okay.
and it had some of the formulas. So we'll have to go back, but I think the p-value is 0.034, and so that's less than, and that's why we would reject. Is that cool for now? And then we'll find the formulas later, each of us individually.
Okay. Okay. When are you taking your exam? Because on Saturday I will ask Adam to help me with that.
I'm taking it early Saturday,
that.
probably, or tomorrow.
Okay, I will try to find it also. If I don't get it, I will ask him.
Okay.
Okay.
I'll try to forward it to you too. I'm sure I'll find it. I actually have another homework assignment I need to do that I need to get onto. So,
Okay. Thank you.
so on the next one, I think you would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical process? And those would be independent sample t-tests because they don't have anything to do with each other.
Oh, okay. I will write it
So,
because anything to do with each other. Okay, I got confused with that. I thought it would be a dependent sample test, but no, right? You have to look at the minimum.
yeah.
Okay, that's the reason. Thank you. I will analyze that. Okay.
Okay.
Okay. Is it me? It says.
Yeah.
Okay, an educator is interested in achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only both brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent samples? Okay, I got it right, but it took me a lot of time to determine that it would be dependent sampling. If you select a brother so as to compare his academic achievement to his sister, you must include the sister in your study.
Yeah. You only had the one choice. You only could use one of his sisters. Whereas if it's just men against women, you could use any woman.
Oh, okay. Okay. Thank you.
Okay. The next one. A soil scientist collected random soil samples from a field and measured this dissolved organic carbon level for each sample. The measurements were recorded. Dissolved organic carbon. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. So this would be you want the confidence interval for the mean when the standard deviation is unknown. Because standard deviation is not going to be given. They never are in these. It's just raw numbers.
Okay. I agree with you.
Okay.
Okay. Yes. Okay. Okay.
I think you got the next one.
Okay. Which of the following is the 95% confidence interval for this data? So we we had to compute our upper and lower bounds and then subtract the lower from the upper bound and then divide it by 2 and I got 2.025.
What'd you get?
Yes, I got it. I agree.
2.025?
I got it. Yes.
And then that lower bound is the 11.168.
Yes.
And the upper is, it's right there for us, it's 15.217.
Yes.
Okay, a random sample of Hummers for sale in Los Angeles and New York were taken from listing at cars.com. The data are recorded in this Excel spreadsheet. We wanted to know if there's a difference in mean listing price between Hummers for sale in Los Angeles and Hummers for sale in New York. Create a 95% confidence interval for the true difference of mean listing price between the two cities. Now, this is for Gabriella to answer. And so she answered confidence interval for mean of the difference using dependent samples is what she said. She said dependent, I think, and it should be independent samples.
Yes, I agree with you about independent samples. Because
yeah, go ahead.
It doesn't, the results we get from LA does not have nothing to do with New York, right? Is
Correct.
that?
Yeah. I mean, they're related, but it's not. It didn't have to do with our selection of Group B.
Okay.
That one's a tricky one, though. It really is, because you're doing, you think, because I'm doing Hummers in New York, and so that's forcing me to do Hummers in LA. But in reality, you're just doing Hummers in two different cities.
Okay. The following, I don't know what happened. I didn't get any results of the ones that they gave me. I want to see how to do that.
Okay, well, for one thing, I got to delete these. Okay. So we have the data, right? It's in these cars.
Yes.
They want Hummers in one and LA in one and New York in two. Right?
Okay.
New York in two.
Yeah.
So let's pull up used Hummers. So this is LA. Down until, wow, there's a lot. And then New York here. And so they say 95% confidence. And what are they looking for? The lower and upper bounds?
Yes.
So it's just
Oh, yes.
I don't
You got it there.
I don't think that number's right. What did I do wrong?
Yes, they are right.
No, the upper bound should be like minus 769.
No, it is right, because
oh, that's right. That's right. It's not 769. It's 50. That's right. I wrote down the wrong answer on this one from a different problem somehow. It's minus 423.2.
Yeah.
Is it 238? I have 158. Hold on just a second here.
Okay.
Do we want to know between the two cities? Did I put this in the wrong one? Should it be in paired samples? Hold on just a second. Whoa. What did I do here? Were there only that number of Hummers?
I think, oh no. Oh yes.
Okay.
Oh, we just have the,
Am I in the wrong one? This is where I get confused sometimes.
okay. You are in paired sample t-test.
And I don't think that's right.
You know, I did it in paired samples and I didn't get the, it was wrong. I think you did right the first time.
Yeah, I
In
think
two
this
samples.
this number's right, but somehow I had gotten 423.158. And I thought I got it
Oh.
right.
That could happen.
What did you put in?
Okay, I got it wrong. You know, I use paired sample and I got it wrong.
I think this is the
Because
right one to use,
okay.
but I just don't. I'm not sure about that number. This 423,238.
And Gabriela,
What did
what
she
did she
say?
wrote? Okay, I will see. It is
She has
number.
238 as well. Maybe that's what we'll just go with that. If we're wrong, we're wrong.
Okay.
But that's what I'm getting here. So I can't duplicate what I got before. Even though I got the right answer, maybe it's within a tolerance or something. And then this one, she got 5417.34. Now 336 is what it should be, but she put it as a negative, and I don't think it should be a negative.
No, it's positive. Positive.
Well, let's put that in.
Okay.
Okay. I think we're done with the used Hummers.
Okay. Gabriela's turn.
I think that was, yeah, it's Gabriella's, I guess. Many studies suggest that there's a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effects of jumping on the bone density of growing rats. There were 3 groups. Rats were selected at random from the 3 groups. A control with no jumping, a low jumping group, the jump height was 30 centimeters, and a high jump group, 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats was measured. The data are recorded in exercise bone density. Researchers would like to determine if the mean level of bone density are different between the 3 different groups of rats listed above. Use a level significance of 0.05. What is the correct hypothesis for this situation? It has to be ANOVA. I don't know if that's what she put. Yeah, she did, because there's 3 instead of just 2.
With you. And then we calculate the test statistic. And when I did it, I got it 7.978.
And what would you get on the other one? 0.002?
Yes.
That's what I got as well. Yes. This is easy. You don't forget which of the Excel spreadsheets you're going to use, because it's the only one that you can put 3 different sets of results in. That's what I like about the ANOVA.
Yes.
Okay. Whose turn is it now? Is it back to me or is it yours? I can't remember.
Okay, I can do it. Which of the following best expresses the conclusion of this test? Use a level of significance of 0.05. Since our p-value is 0.002, it is less than 0.05, so we reject the null, and there is sufficient evidence to conclude that the bond density of at least one of the group is different from the bond density of at least one of other groups.
Great. Perfect. Okay, so
Okay.
hopefully these are the last 4 questions, I do believe. Pressures of supply and demand act directly on the prices of airline tickets. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. The study was undertaken to determine if there's a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with the ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket from London Heathrow to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe were recorded for each scheduled flight 90 days in advance, and then again 14 days in advance. The data are recorded. Direct flight costs. Perform a hypothesis test to determine if there's a difference in the mean cost of nonstop flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use a level of significance of 10.1. For the next 4 questions, do 14 days, 90 days for the analysis. So what is the correct type of hypothesis test? And it would be dependent sample test.
Yes, I agree with you.
See, and that's where it comes, it's really hard to, the Hummers were independent, but these are dependent. And that's where it was hard. But I think that these are dependent because there's only one flight that you could choose from. It's not just any, on the Hummer, you could choose any sale that occurred in the New York area. But here it's specific to, one airline's, you have to use that airline's other flight.
Okay.
But that was confusing to me.
Yes, it was confused to me also. I agree with you. And since we use the values in our sample test, we got the test statistic 1.685, right?
Excuse me?
In the test statistic, I got 1.685.
That's what I got too.
Okay.
And the p-value I got was 0.096. Is that what you got?
Yes, I got it. Yes.
Okay.
Gabriela's turn.
Yeah. So it says, which of the following best expresses the conclusion of this test? Use a level of significance of 0.1. And what did she write here? She said, there is sufficient evidence to conclude that there is a difference in the mean cost of tickets purchased 14 days in advance. So what was that? Is that B here? And I agree with that.
See, it would be B. There is sufficient evidence to conclude that there's
Right.
mean. Yes. Okay, the second one, right?
Yep. Do you agree with that?
Yes, I agree with that.
Okay, let's go ahead and submit this thing and see what we came up with here.
Okay.
So far, so good.
Oh, that's great.
Good. Now, I just have to go back and find that stupid formula.
Okay. Okay, Ben. Thank you
Okay.
very much.
I'll make sure to publish this. Okay.
Okay. Thank
Thank
you.
you.
Thank you very much. If you find the formula, can you please
I'll
send
email
it
it
to
to you.
us?
Yep, I will.
Thank
And
you.
no problem. And then Tuesday at 9 o'clock.
Yes, it's okay.
Okay. Sounds good. Thank you.
Bye bye. Thank you.
Bye.
Bye.